Hello everyone, and welcome back to another GIS Mathematics lecture video. And in this lecture video, I want to talk about this idea of an inverse matrix. And I'm going to talk about it conceptually in this video. Then I'm going to move into examples in the next couple of videos. So if you're a little bit shaky on reduced row echelon form and the identity matrix, the next few videos will hopefully reinforce the concepts. But if you feel really uncomfortable, I strongly encourage you to go back and rewatch those videos before continuing after this one. But let's talk about inverse matrices for a second. And what I want to do is I want to talk, before we talk about the inverse matrix, what it means to be an inverse. Right, what does it mean to be an inverse? Well, let's just think for a second about some scalars, right? General numbers that we know and can think about, right? So if we have 2, the number 2, right? What's the inverse of 2? Well, hopefully we all know that it's 1/2. Right? Similarly, right? What's the inverse of 1/2? Well, that's just 2, right? So what's the inverse of, say, 4/3? Well, it's 3/4. Right. So hopefully this makes sense. Hopefully I'm not teaching you anything new here. I'm just giving you some examples of an inverse. But what I want to do is I want to propose a different definition of an inverse, right? And that's this idea that you can have. Actually, before I take up the addition, let's just do a quick piece of notation, right? If you want to get the inverse of something, say the inverse of 2, right? You would put 2, and then if you want to designate that you're talking about the inverse, you put a -1 there, right? That's the same as saying 1/2, right? And we can generalize that by saying a to the -1, right? It means the inverse of a. That's the same as saying 1/a. Or if you have 1/a, the inverse of that, right, that's the same thing as saying a. So I've just taken these examples, I've added some notation, and I've made it a little more generic. Right? So what I want to do is I want to actually propose a definition of an inverse. Right? What does it actually mean to say that 2.5 are inverses of each other? What does it actually mean to say that? Well, if we go back to our sort of generic term here, right, we can say that a times, right, a inverse is equal to 1, right? In the same way that 2 times 1/2 is 1, in the same way that 4/3 times 3/4 is 1, right? A times a inverse is equal to 1. This is the definition of an inverse. Hopefully I haven't broken your brain. Hopefully you can follow that logic here, that we can define an inverse as the relationship between a number and what we're calling its inverse to this concept of 1. Okay? So from this sort of logical conclusion here, we can use this definition to wrap our minds around the idea of an inverse matrix. Because we have this idea of A in matrix form, we have this idea of 1 in matrix form, and we can set up this exact same equation to figure out what the inverse of a matrix would be. Right? And so what we can do here is matrix form. right? We designate a matrix, as always, with a capital letter. Right? We can designate multiplication, right? And we can designate inverse in the same way, right? The variable that we call the matrix with a -1, right? Just like with our scalar up here, right? This notation, this -1 notation, means inverse, okay? So I'm hopefully not introducing anything new. Now, in order for these two things to hold true, right, the definition of the inverse for numbers and the definition of the inverse for matrices, we have to transport down what is the matrix equivalent of 1. All right, well, the matrix equivalent of 1 we've already discussed as the identity matrix, right? We've already discussed this idea that these three things, right? This is our matrix. This is what we're calling the inverse. We don't know what it is yet. But again, these two things times each other is going to give us this thing that we do know. Okay? So hopefully that makes sense. This is actually where we're going to stop this video, is just this idea that we can take the definition of an inverse, apply that same concept to matrices. And then in the next video, we'll go through sort of setting up how we would solve this conceptually. And then we'll move forward to some concrete examples. So hopefully this makes sense. And if you have any questions, please reach out. Thank you.